So today we are going to be talking about property-based testing. Kit had expressed an interest in that, so I thought that would be a fun topic for us to spend a little bit of time on. So let me share my screen here and we can dive in. It's a little bit bigger. All right, can everyone see that? I've got you guys over on another screen, so I'll just make sure you can view. Oops. All right, awesome. Okay, so what we're interested in implementing is something like what we have in Zeotest, but we're obviously not going to depend on Zeotest because that would take away all of the fun. But what we're going to want to build up to is being able to write something like, let's just say like check gen.int and then we'll pick our thing, or maybe we'll do like 3. We'll want to do something like this, and then we could do like XYZ, and we could say left is equal to, we'll just associate both ways, and we'll say, we want to be able to say like integer addition is associative here. So this is what we'd like to build up to. And we're not obviously going to build all the infrastructure that we have in Zeotest, but we'll try to kind of develop some of the intuitions and see if we can maybe get to the point of this working. Oh, it looks like Kit's here. So hold on a sec. Let me first promote Kit here. All right, we're going to promote Kit to panelist. And then I think we had one question. Any chance to enable chat versus the Q&A? I'm not sure.
Hello, sorry.
Hey, how's it going? No, you're great. Let me see. I don't know if I know how to enable chat, so we may just leave that as is. Okay. No, you were. Hey, kid, how's it going, by the way?
It's going well. It's going well. Yeah. Don't worry about me. Excited to learn about Gen.
Excellent. So I was just kind of framing the problem of saying, like, can we get to the point of implementing something like this? I think if we could do that, that would be pretty nice.
That'd be brilliant.
So if we kind of break down what we would need for this to actually work, so it seems like we need some kind of gen type that describes a generator of values of a given type. And then we need this check method that runs one or more generators and uses the values to test some predicate here. So why don't we start sketching that out a little more in code here. I think this should actually be here. Make sure it's working. We'll just compile this. Okay, great. Okay, so I think maybe the first thing we can do here is we can make a new file. And so we're going to want to have one file for our generator here. So we can call this trait gen. And I think initially, we'll just right now call it gen. We'll add type parameters to it for a second. And then why don't we actually maybe make a new, let's put this all in like a like testing folder, say. And then in here, let's also make a package object testing.scala. And so we'll have some kind of check method here, which we'll fill in a second. And then we'll have our gen type, which will be in our little package testing. And then we'll have our little example that we can eventually use to run this. So here we will, we'll just make a package. So we'll make this package testing as well. And then we can use this stuff here. Okay, so let's maybe start with this generator type. So this generator is going to need to know how to generate values of a given type. Potentially, we could use some environment, but maybe since we're keeping stuff simple, we won't even use the environment yet. And this is going to be one of those nice cases where we're going to get a lot of mileage for free out of Zio. So I'm actually going to be able to implement this gen initially just in terms of a Zio that produces this value. And so in here, we're going to need a bunch of different constructors of generators for different types. Oh, let's import Zio here.
Yes.
All is important. And then once we have this generator in here, we're going to have some check method. And so it seems like this is maybe going to have one of these generators. That's a generator of A. And then it's going to have a function. I think here we'll just do A to a Boolean. Like in real Zio test, this isn't a Boolean. This is this like fancy test result and has even more fanciness than Kit did. But I think here we'll just make this a Boolean. And maybe this whole thing then, maybe initially it will, we can either have this return a value or maybe we can have it return some kind of debug statement. But maybe initially I'm just going to do the simplest possible thing. And I'm going to have this return a Boolean itself. It's just going to be, did this property-based test pass or not? And then eventually we can make this a more complex type that maybe has information on like how many tests did we have to run before it failed, what was the failing case, things like that. But I think initially we'll do like the minimum possible work here. And again, I'll import Zio. And if I had this, we could imagine I could also have a couple of overloaded variants of this. So I could have one like takes like 2 gens. So maybe I'll call this like first and second. So a gen of B. And then this will take an A and a B. And I could overload it again. Oops. Yeah, this is probably a good one for Copilot. And so if I have this, and let's imagine right now that I have a generator of ints here. Then I can actually take my example. And this can now, I think, just about be real code. Let's see, why is this not found? Let's see, so this should be package object.
It's a package object inside of package testing, so you just remove that package object.
Oh, I shouldn't have done that, yes. There we go.
Package objects are weird.
So now this is actually, I mean, I was just going to blow up because I haven't implemented anything, but this is now actually compiling code. And so maybe I could call this like test result equals this. And then I could do test result debug.
By the way, Vlad asked if said you seem to be using Copilot. Are you? And I think Yes, that's what's creating
Yes,
those
yes, I,
great
I am
outputs.
using Copilot. I'm getting the productivity I can out of our artificial intelligence before it takes over everything.
Indeed.
Okay, so we've got a little bit of a choice here of just do we want to work on the generator or we want to work on the check method first? I think we can kind of do one or the other, but maybe we should play with the generator first. And so at least for this example, and really even as we go on, but especially this first example, it's going to be pretty straightforward because we're able to rely on a lot of functionality from Zio, and in particular on this random service that Zio has. So I could do something like I could maybe even have a constructor. Maybe I'll call this from random. And this is going to give me access to a random service and let me do something with it. And it'll construct one of these generators. And so here I could do something like I could do gen, and then I could do Zio dot, and these aren't, this used to be like service with Zio random, but now the default services aren't in the environment anymore. So I've got this random with, and then this takes a function from a random to a Zio, and this is a function from a random to a Zio. So this could just be gen Zio dot random with f. So now if I wanted to generate a random int here, I could just do from random blank dot next int. And maybe I want to be able to do something with this, and depending on how well, I've got this sample, so maybe that's fine. So just with this then, maybe if we want to just like demo this, I could now do like gen.int.sample. Maybe I want to repeat this 100 times. I'll debug each of them just to see it. And I could run this. Oops. What my, oh, I should not define this as a val yet because I haven't implemented the check method. So I'll make this a lazy val. And I've got lots of random numbers here.
Lovely.
So obviously this is like almost the simplest possible generator you can do because it's just completely arbitrary random numbers, but this actually ends up being the basis of almost everything else because I can usually apply some function on this to generate other things. So if I want to do Booleans, I can partition this into even or odds or which digit I end with or whatever other logic I want to. But if I do something that's basically 50-50 for that space, then I can generate Booleans for this. And if I want to generate any like characters or anything that has X number of cases, I can basically do a modulo operator on this. And we can pretty quickly compose these generators to create generators for more specific data types and for lists and for products of different data types. So we'll do some of that, but it's nice to just have at least a basic generator working here. Now, one thing to note about this is using the random service. And so right now it's just using Zio's default random service, which is based on Scala's, just the default built-in Scala util.random. So that is, it's not purely functional in that under the hood, there's, this is mutating some internal state. And every time I like start up my program, it's going to generate a new set of these numbers here. So like here, this started with 144. Let me run it again. Now it's going to start with 228. So in a way, this isn't the perfect thing we would want. The perfect thing we'd want is to use a different implementation of this random service that starts with a fixed seed here and is actually implemented slightly differently. I think we may defer that from this discussion here but I did want to just like highlight that for you. Okay,
Cool.
so yeah, I'm sorry, go ahead.
I was just going to say, people can, definitely look at we'll link to the real file where this is on GitHub if you want to compare and contrast.
Yeah, exactly. Okay, so we've got the ability to implement these random numbers. We'll want other generators, but maybe let's try to get our initial example working first. So to do that, we're going to need to implement this check method here. And so if we think about what this needs to do, we basically need to generate a number of samples from our generator. We need to run the predicate for each of them. And then if the predicate is satisfied for all of them, we succeed. And otherwise, we fail on the first failure. So I think one easy way to do this, there's actually a nice streaming solution for this. And maybe, let me see if I can add that to my dependencies. So if I have this generator, I could sample it to get a value. And then I could do zstream dot, it's called repeat zio, gen.sample. I may be in the point where this is not actually going to be giving me help. But let's say that I'm going to repeat this. So this is just going to give me an infinite stream of these generated values. And if I wanted, I could just map these values with this function at this point. And then I could take 100 of these, and then I could run. I have a zsync. Let's see if I have zsync for all. Let's see if that seems plausible, but let's see if okay, first off, we have unresolved dependencies. Is it zio stream or zio streams? I always forget what we do here. Let's see.
Oh, I think
Okay,
the
that
import,
seems more
the
promising.
package is singular, but the import is plural.
Yeah, which maybe it's not the best, but is what it is. Okay, so we've got that. Let's now see if the operators I made up, they seem to be real, which is lovely. Okay, so let's now, okay, so we've got this version, which we'll assume for a sec is working. We'll verify that shortly. So then if we have this, these versions are actually just kind of slight, or will be slight variations of this. Let's think about what we would need to do for these to be variations, and then we can actually do the thing. So what I would like to be able to do here is I would like to be able to say something like, I just want to delegate to this check here. So I'd like to be able to do something like first and zip it with the second. And then I probably need to do this tuple thing and just have that be the implementation here. But that is obviously not going to work because I don't have any operators on gen yet. So let's start changing that. So one of the, at least right now, this implementation of gen is really simple in that it just is zio. So it makes it really easy to implement any operators on this generator by just delegating to the operators on zio. So let's do a couple of these. So if I want to map a generator, I'm just going to sample the original generator and then map over its output. if I want to flat map the generator, then I can just sample the first one, use to produce a new generator, and then sample that one. And then if I've got those two, I can do zip with the same way I always do. Well, here I can do it on Zio, or now that I have flat map, I can just do self, self, flat map A, dot map B, F A and B. And I kind of ideally, I want to limit the number of times I'm using this primitive representation of the Zio so that if I change this, I don't have to refactor as many things. So if I have zip with, then it's easy for me to have zip that can just be zip with that and tuple these things. Oops, what did I do? Why do I not have? So oh, extra parentheses. Okay. And then I can give myself a little symbolic operator here if I want to. That'll just be zip. And so now I can undo this, and this should compile. And now let's go back to our little example, and let's just check that our little zipping was not entirely crazy. So I'm going to do gen int.zip gen.int. And let's just print out a bunch of those. And we've got random pairs now. So then I can do the same thing here. So this time I'll do first, second, third, and then I think I'm not going to quite, let's see, I don't think that tuple is quite going to work when, yeah. So these are not the compositional zips from Zio. We could actually do that here, but we haven't done that here right now. So they've got this nested structure, which is fine. I mean, we could go back and make all this stuff use the compositional zips, but let's just do it the old-fashioned way here. Unpack those ourselves. And so you can see it's pretty easy for us to just add these arities. So if we wanted to, and probably Copilot could just blow through this. Yep, let's add a few more arities just for the heck of it. What did we get one? Oh, because it went in alphabetical order and the F interferes with the F in the function. All right, so I'll leave it at 5 for now. But yeah, so Copilot's great at stuff like this, or like if you're implementing accessors for Zio services, it's great at knocking this stuff out. So now I think we're actually ready to go back to running our original motivating example. So let's try running this. So this test passed, which is correct. That should be a true property. What's another property that is not going to be true?
Add a minus in there.
I guess.
Yeah.
Yeah. Yeah. An easy one is, yeah. So subtraction is not associated. These are not going to be the same. So let's run this. And it does say it's false. So, I mean, this is already in like less than half an hour, like not bad. We've got some basic generators. We've got a way to test these generators. They're giving us some type of result here. But there's always more stuff we can do. So some things we can think about is more generator constructors and operators, right? Right now we we can do different numbers of integers, but we can't do much else. So, and we can't even do like bounded integers. So we should try to make that more exciting. That's one thing we can do. Another thing we could do is, I'll call it better error reporting. So right now, when this fails, it just said false, but it didn't kind of tell us like what these values were when it failed. So those are, I think, two things we could explore. But let me maybe check in and see if anyone had any questions on this before we go on. Oh, okay, perfect. Yeah, so Naveed said recipe is accessible. Yeah, I mean, maybe some of that will come back with macros, but I think some of this AI stuff is also changing the equation bit on some of that boilerplate generation. But I see there's a question from HKT. So let me see. I can. Hey, go for it.
Oh, my bad. I didn't see you. My hand was raised. I'm so sorry.
Oh, no worries. No. Nice to hear your voice. Okay, so why don't we try to make our result reporting a little bit better here? I think that might be a nice thing to do. So to do that, let's maybe create a new data type for this called test result.scala. So this will also be in package testing. And I'm just doing this on the fly, but I think it might make sense for the test result to be like a sealed trait because it really has like different cases of it like passed or failed. So maybe that's going to be the most basic thing. So let's just capture that first. So yeah, maybe success and failure. Maybe that's just as good. And then probably if we have a fail, maybe in a success case, we're not going to need any additional information about this. But maybe in the failure case, we are going to need some additional information about this. So maybe initially it seems like we would want to know maybe what the inputs were. So maybe this is going to be just a list of strings initially. So that when this test fails, we get some reporting on what those were. So if we've got that, then maybe we can make another little helper for ourselves here. Maybe we have something that we call like test. And this maybe is going to take a value of type A. Just thinking as we go here. And maybe it's going to take a function from an A to a Boolean. Eventually, we might want to have these be able to take zeros too, because people want to do like property-based tests with the zero stuff, but we'll defer that as well. And this is going to return one of these test results. And so we might do something. Let's maybe suspend this whole thing, just so we're safe. And we'll say if the test passes, then we'll return a success. And if it fails, I think one of the things we're saying here is, at least if we want to have one, maybe we'll kind of stringify everything. So maybe this doesn't actually need to be a list. Maybe this can just be a single A. So let me make that change here. Okay, so now when we go to our check method here, we can change these, return test results as well. And so now, instead of mapping that with F, we're now going to map ZO, and we're going to take the A to a test A with F. And now, instead of just, so we're basically going to want to take all of these, and we are going to want to take until we get a failure, I believe. So let's see if we can do that. So we'll do Z-sync. Well, I guess an easy thing, maybe let's just do the easy thing right now, is let's just collect these 100, and then let's collect case. I think we do collect first then. This is a chunk now. Let's see, run collect is going to give us a ZO. So sorry, let me map this. So I do results, collect first. And I can say, here.
Oh, I think you'll need to make that a plural on the end of line 18. Results.
Results. Yep. Thank you. Let's see. Okay. Yeah. Test result dot failure. Be important. And then gen sample dot flat map.
That is big play, yeah.
Okay. And then test result failure. Okay. So now this is going to give me back either the first failure that occurs, if there was one, or otherwise it's going to give me back a test result success. And then if I wanted to, let me maybe make one other helper method to like report this. So maybe I'll call this report. And this will take a test result. It's a test result. This will give me a zero, any nothing unit. And then we could do something like we could match on this test result. And so we could start with something like, hold on, the test passed. And we could start to even think here about some other things we might want, right? Maybe we want like number of tests run, name of test, etc. But also we're we're not going to have all the test framework here. So some of these we can just make notes to ourselves for. And then here we could say something like, yeah, test fail inputs. And then I just need to do the or die on here, so this doesn't throw an IO exception. Okay. And so now I could go back to my example here. And now I could do like test result flat map port. And let's run this. And now we've got some examples of our failing inputs here. And if we wanted to, we could try to keep this in a more structured format so it wasn't just a tuple here. Another thing that I think will probably be outside the scope of this Zymposium is like what the actual ZO test does here is it has a concept of shrinking. So once it gets to a failure, it'll try to make these failures smaller so that I mean, this is like, it's true, it violates this property, but it would be like a lot clearer if this was like 1 and 2 and -1 or something, versus these kind of big numbers. But this is now kind of giving us an example of failure here. Or if we go back and we make these addition, so now this property is true, this test should pass. And now we've got the test passed. Okay, so I think that's a decent amount of work, at least initially, on the implementation of the check method here. So then the other thing we can go is we can go back and we can do some more work on this generator type and implement some more operators on it. And let me just check in on our.
Yeah, we seem to be good so far.
Okay, excellent. All right, good. Okay, so let's try to implement a couple of other constructors, and then maybe a couple of other operators here to combine these. So we can get a decent number of them just by kind of leveraging the functionality of that random. So like if I want to generate Booleans, I can do next Boolean. Maybe I want another of, maybe I call this like def int bounded. And this is going to take a min and a max. And oh, maybe I'll call this in between actually. Just I think that's what this one's called. In between, I believe. Yep. And n. And I could do like a bounded. And I think this just takes a max because the yeah. Okay. So now we've got a good number of ways of generating integers within different ranges. Let's do something now a little bit more complicated, maybe. So another thing we might want to do is you might want to have something like collect all. And so this is going to take an iterable of generators and return back a generator of a list of these things. And we can either do it in terms of Zio's collect all here, or we could do it ourselves. Either way, we've got in terms of Zio's collect all here. And so this then is going to let us implement something like, if you've used Zio test, you've probably seen this like, let's do a couple of these. So first, let's do like a list of n. So this, you say, hey, I want a list that's this size of values of this type. And it's going to generate you a list of these things. And all that is, well, we're going to just fill up a list of these generators of the specified size. And then we're going to collect all of these together. And then with that, I could do, just if you use the test, there's another one that's just called list of. It doesn't take the n. And this is just going to use some default size. So maybe I'll just make a note here. And so maybe these ones right now will be like relatively small. We could do gen dot int between, say, 0 and 10. Gen dot list of n gen. And open. And so just with these, as well as with this like map and flat map, we already, let me implement one more that's pretty useful. So another one that you may have used is one called elements. And so this is going to take some variable arguments of A, and it's going to generate one of those values. And so what it's going to do is it's just going to generate a random integer between 0 and the size of this thing. And then it's just going to look up the appropriate one. So let's see some of these in action. Let's go back to my example. So maybe I have something like field trait animals or animal. I can have like object animal. And then, yeah, let's say initially that everything's a dog, a cat, or a bird. So then I could do something like val gen animals is equal to gen dot elements dog cat bird. I'll import animal dot all here. And so now let's go back and let's just start by debugging these things. So let's do gen animals. Why? Huh? Why was that not repeated? Okay, that's interesting. Why are we not repeating that? Okay, so that's working. Oh, I know why, because I have the debug in the wrong place. Dot debug. Yeah,
Oh,
that
yeah.
was silly of me. And so we get lots of dogs and birds and cats. So that ends up being a pretty nice one as well. And then we can start to use these to construct some other like more sophisticated generators. So like let me do another one of so just like we did this list of, which just kind of does a list of arbitrary things. Let's we can do a couple of others. So let me see if I can do one for I'm not sure it's actually an operator on random. I may need to map it myself, but yeah. So I could do something like next and bounded, and then map that to a car. Not just sorry. Okay, so now I've got a generator some characters. And then one way I could think of a string is just as a list of characters. So then I could go down here and I could have one that I call like string n. And then I could have another one that I just call string. And we could have variants of this to take different character constructors if we want to decide whether they're like alphanumeric characters or various kinds of characters, but we can probably start with this. And with having some of these basic ones and having these operators to compose them, like particularly this like zip with flat map, we can already like start to create generators for more advanced types. So like, let's say that these animals each have some properties of their own. So like the dog maybe has name, that's a string, and an age, that's an int. The cats, they also have a name and an age, but they're more particular. So they also have a food that they eat, and the birds are just birds. And food, what are some different fancy foods that a cat might like?
Ooh, what do my cats
Uh-huh.
eat? They have weird taste.
Fish?
Broccoli.
Do they like fish?
Oh, they love fish. They're fans of fish.
Do they like meat?
Yeah, generic meat, sure. Yeah, broccoli, I think, is a weird one. I don't know, but they seem to like that.
All right. All right.
I
Well,
might be
there you
crazy.
go.
If broccoli is
Okay.
poison for cats, I swear I don't feed it to them.
Okay,
like some
maybe we
weird
shouldn't
shit.
do this. All right, we'll comment that one out. So then let's see. Oh, and now I need to make these case classes. All right. And so just with this, I can already, like, let's do Belgian dog is going to be a gen of dogs. That's going to be something. Belgian cat will be a gen of cat. Anything else? Belgian bird. Gen birds, maybe something else. Oh, I think this does need to be the bird type, just case options. Oh wait, oh no, wait, what is, oh, these are animals. No, I imported them all, I thought. Didn't I? No. Yeah. Okay. Okay. And so now then, I think this isn't going to make so much sense. And we'll come back to this in a second. So I think I'm going to need one more operator here to do this. So we go back to gen, and I'm going to have another operator that's a little bit like elements, but is going to operate on generators instead of on values. So I could call this maybe one of a, and this will be a's, but this will now be a gen of a. And it's going to be the same thing, except I'm going to use flat map here. So now I can go back here, and so now I can have something like val gen animal, gen of animal. Make sure I actually had these good. I actually did have them extend animal, which is excellent. So this could be gen.1 of these three gens. And then let's do each of these. So let me get one more gen here. I'll call this one constant. So this will kind of be like the ZO succeed of gens. Just put this value in there. So then I could say, okay, my generative bird is just going to be then got constant bird, because the bird doesn't have anything else in it. Constant. And then let's do these. So a dog has a name and an age. And because I implemented the flat map and the map, I can use a for comprehension here, which is very nice. And I can generate these however I want. So I guess Copilot liked using the elements to pick one of these particular names, which is fine. We could have also just done a random string, though we would have probably got nonsense that would have not have been as nice of a human readable name. But this is a very idiomatic pattern of, like, if we have a case class, we generate an element for each of the case classes, and then in the yield statement, we put them together. So that looks very lovely. And let's see what we come up with for this. Okay, so at least here, cats and dogs have the same lives. I really don't know. I'm not a big pet person, so I don't know if that's true or not, but fair enough. And we've got some names that are probably appropriate for cats and dogs. And so with this, let's now generate some new fancy animals. Let's see, I think I'm just missing. Oh, yeah, I have an extra brace there. Oh, it's called just gen animal. Okay. All right. So let's run that. And suddenly we have a whole list of not crazy looking animals. And we can do something if we want with them. If we want to be silly, maybe we do have some broccoli in our food. But then maybe we'll add some new method. Let's see. Why don't we have do not poison. It's going to return back a new animal. And well, actually, I think that's the opposite of do not poison right now. But we will default them to having fish. So now we could make a new property-based test involving this. So we could say, well, I guess we'll need some other method. Let's make is poisoned. And no, the meat doesn't, I don't think the meat poisoned the cat. I don't know, someone's gonna have to verify for me on that. I think it's the broccoli that poisons the cat. Maybe I'll call this feed appropriate food. So then here, let me create a new test down here. So let's call this animal safety test. So we'll say this will be our gen animal. And so this will be animal. And so we could say, let's see, animal dot feed appropriate food that is poisoned equals false. That seems like it should be a property, it should be true. And then instead of doing this manual stuff, we could do animal safety test. And then we have that flat map. And let's run that. And I think we just need some fixes here, or just do an import, but we're going to do that. Yep. Okay, so this test passed. And now let's say this thing actually doesn't do anything. Let's just say this turns back the same one. We should get a test failure here. And yes, if we did not have an appropriate implementation of our feed appropriate food, then poor Felix, 4 years old with broccoli, is not going to be happy, assuming our little example about animal cat food is correct. Any questions on that up to this point? Nice fish chicken. Looks like Naveed is typing something.
Delicious.
So, oh, and we got a Q&A up here. Can I explain elements one more time? Sure. Yeah, I did that pretty quickly. So let me go to that. So elements, and yeah, I think maybe this is a good one to unpack a little bit because there are a couple of like little bit of Scala-isms in here. So the first thing to note about this is this is an A with this star syntax. So what the star syntax means is it accepts a variable list of arguments. So the user experience I'm supporting with this is that I could do something like gen.elements 1, 2, 3, or I could do gen.elements 1, or I could do gen.elements 1, 2, 3, 4, 5. So that variable argument syntax is actually pretty common. Like if you just do like list 1, 2, 3, 4, 5, the way that works and it constructs a list, whether you give it 1 argument or 20 arguments, is this variable argument syntax. So I think you've probably used it a lot as a consumer. You may or may not have implemented a method that used it. But the way you actually write a method that has that kind of behavior is you do this little star after the type. So it's kind of weird, but I guess you had to have some character to denote wanting that behavior, and the one they chose is the star. And what that means internally is if I'm working with this in here, if I do val x equals a's, let me see if I can hover over this. Yeah, so you'll see that the type of something with this a star expression is a sequence. And a sequence is a linear collection. So I've got this this sequence, and I think the default implementation is an index sequence. I think maybe a vector. Let's see. Maybe we can print line some x's here, and let's see if this will actually tell us something. An array sequence. Okay, so the array sequence is the default implementation of this, at least on the Scala version we're working on, which is Scala 3.2, or use the same collections as Scala 2.13. But anyway, so this is basically just a sequence, and as you can see here, the implementation does support efficient index access. So I've got this list that just if we wanted an example, right, we could imagine this is just like a, well, I guess it's an array sequence. Yeah, let's just take one of these. So this is a array sequence of Fido, Rex, and Snoopy. And what I want to do is I just want to take one of those three values at random. So sometimes I'll take Fido, sometimes I'll take Rex, sometimes I'll take Snoopy. And so what I'm going to do is I'm going to use this from random function again. And actually, I didn't really even need to do this. So I could probably simplify this. So let's use the gen operators directly. So I could just do gen dot int bounded a's dot size, or I could do a's dot length here, I believe. And so this here is just going to generate a random integer between 0 and the length of this, and it's going to do it exclusively. So if this is a length 3, it's going to generate either 0, 1, or 2. And then it's going to take that, and I'm just going to treat that as an index. And then all I'm going to do, I don't even need a map, I can flatten, I can just use a map, is I'm just going to index into that array sequence with that index. So I'm just picking a random one of these three values. So there's really nothing that's special with it, but it's a pretty convenient one. A lot of times people want to kind of just generate one of a specified number of values, and it lets you do that. And if we want to, I could even just add some debug statements. You can see this. So you can see it generates 2, we get Snoopy, it generates 1. Well, then it's looking at the cats instead of dogs, so 1, I guess, is Tom, and so on. But that's all that gen.elements is doing. Does that answer your question there? Yeah, exactly. It's like one of, but on the, so let me just mark this done. Right, so then Pavel has the question of, okay, if we want the test to be reproducible, how do we do that? And so I guess the most basic answer is that's why you use ZeoTest, and then it sets its own seed for the random value, and then that works. But let me show us maybe a way that we can do that here. So I think we can look at our check method maybe. Let's see. Yeah, so let's start with maybe slightly hacky way to do it. So I could do something like, let's say, Zeo dot, I believe it's called with random. Let me just make sure I've got that operator right, and then we'll look at what we can do here. Yeah. So this with random is going to run whatever is inside this block with the specified implementation of the random service. And so then I could do something like random. And then let's see, this is where I really, oh, let's see. Look at that. VS Code's actually working for me right now. So I think I have one where I can create a my own Scala random. Let's see. I think it's like Scala random. Let's see. Yeah. All right. So here we go. Random Scala. Okay. So let me do that one. Look at that. It's so nice when you can actually click through things. Kid is like laughing at me because he's like, I always get this on IntelliJ. So this is going to be random Scala. And then I could do something like new Scala util dot random. And then let's just say we're going to use 42 for our seed here. And now this should be deterministic. Let's try running our example. Okay, so let's see. We're back to our animal safety test. Let's make sure that our thing is actually doing what it's supposed to do. Let's see. So this needs to be an animal. Oh, no, it was doing what it was supposed to do. So fish. Okay. So now let's start by running this. Okay, and now let's do something. Let's debug each of these inputs just so we see what they are. So let me do that for a second. Or actually, you know, we'll just go back to, yeah, we'll do that. Let's see, I'll go to here and my check method. And so I'm going to debug what we sampled. So let's try running this. Okay, so here we had bird, Fido4, Rex5. If I run it again, I should get the same thing. Bird, Fido4, Rex5, or Fido4, Rex5. So that's kind of in principle how we make sure that these are reproducible. I mean, this is maybe a little bit kludgy doing it this way. Do we want to do it here, or do we want to do it at a little bit of a higher level, like in ZOTest, we would actually do it for each individual test. But I mean, this actually works totally fine for our purposes here. Okay. All right, cool. All right. So I think we're at about an hour here. Let me just check in on the Discord and
yeah, let's just start shrinking now. Can... Perfect. Just kidding.
Is the real check intelligent in? Oh, so Naveed has a question. Is the real check intelligent in what is sufficient? So I guess it depends maybe what you mean on how intelligent. So you can see here we just hard coded in at 200. What ZOTest actually does is there's something called test config, and it has parameters like how many samples to run. It also has a concept of size. So like if you remember when we did our generator .list of, I just kind of arbitrarily picked like the list should be between 0 and 10, which is not crazy, but is completely arbitrary. In ZOTest itself, this is controlled by a parameter called the size parameter. So it determines just like how large the data structures are you generate when they have some sense of size. If you have some concept of minimizing test failures, it also describes how many shrinkings you want to do. It also describes like how many times you want to repeat or retry tests, aside from property-based testing. So it's intelligent in the sense that it uses that input. And it's also a little bit smarter than this in that it just stops on the first failure. So this is a little bit of a simple implementation here. It's just going to take 100 results and then it's going to check if there's a failure success, versus we could be a little bit smarter here and we could only run them until we get a failure. So it's smart in that way. It doesn't have, it's looking for 100% success. So it doesn't have some concept of like statistical significance. You could imagine if you had something that you wanted to pass 95% of the time, there's like some smarter statistical thing of like, well, I want to like run the test until I know that it passes 95% of the time within a 2.5% confidence interval or something. And I mean, that could be a cool thing to do. That's kind of not typical property-based testing, just because we usually ideally want to test to always pass instead of pass a certain amount of the time within some confidence interval. But yeah, hopefully that answers your question. Okay, and yeah, so I think that's hopefully a good overview of how property-based testing works. And I mean, I think you can see here that largely just because we're able to leverage a lot of infrastructure in Zio, we were able to pretty quickly do this. And I mean, get to the point where for arbitrary user-defined data structures, we were generating values that met specific requirements, and then we were testing them. We were getting useful output for it. So there's definitely more that you can do here. Probably some of the big things is one is that concept of shrinking. That's kind of one of the more like, I guess, industrial strength features that you get when you use the real one and not a simple imitation like this. And then there's also some interesting stuff around how you generate functions, which we haven't done here, but you can actually generate functions. And that's kind of cool. But yeah, I think this is hopefully a good overview. And then, yeah, I guess Juan said maybe we could do a follow-up on applying property-based testing to some test cases. Yeah, that could be cool. And maybe that could also be a fun thing. So property-based testing can be really good. Another thing that can be really good is just the non-flaky operator in Zio. I'm not sure how many folks are using that, but that can be a really good one, especially when you're doing things with concurrency. With concurrency, sometimes there's orderings that are not directly within our control in our typical program. And so that non-flaky can be a good way of kind of doing a in the field property-based test, you could say, of making sure some property is reliable for a lot of different executions that may have different execution orderings. So that in combination with property-based testing can be a pretty cool tool for getting to like a little bit closer to like maybe real life situations of like, it's fun here to say like, oh, I must make sure we like feed the cat the right food, but it can really be useful to check for things like concurrency bugs or like what properties can you expect? Like I think we've done some other sessions of if you update two refs, like what guarantees do you have or don't you have about the consistency between those values. And yeah, maybe we can kind of do some examples where we play with something like this, but we kind of use it to get into some more real world stuff like that. All right, well, cool. I'm just gonna do one more check in here on any other questions, and then we can wrap it up for the day.
I think we're good. I actually have one last question, just because I'm sure you get this question a lot, as do I, which is if you do want to do some open source stuff, what's available? Is there anything in Gen? Are there any sort of open source opportunities? How's Gen doing these days? Does it need any help, any love, any more generators, anything like that? Or is this like one of the relatively settled parts of the
I think
Zio?
Gen is pretty mature. I think in Zio test, probably one area that could use some love. And I mean, maybe you want to, if you have any interest in like mentor people, or I mean, I can as well. But I think there are a couple of things with like the assertions and kind of like the way they're rendered that could use some attention.
Sure.
But I think that's probably the biggest thing there, which admittedly kind of has, depending on your passion for testing, may or may not be the most exciting thing, which is maybe why that some of those issues are still outstanding. But I think big picture, like if you are looking to get involved in open source, my advice is always like find a combination of something that you're personally excited about, hopefully maybe know something about, and a project that is kind of actively growing and is in a little bit of like the earlier stages of its life cycle, just because there's like, it's probably like anything else, like in finance or getting a job, like, it's better to get a job in like the growing industry versus the industry that's mature, that kind of thing. But just if there's a project that's kind of growing, there's always a lot of new stuff being added. There's more opportunity for you to take something on and really take ownership of it and kind of grow yourself and grow your contributions and your responsibilities with the project. So like I would say Zio HTTP right now is like a really good example of that. I mean, that's going to be a super important project. Lots of people are either using it or are very eager to use it and want new features for it. And there's a lot of stuff being added. A lot of people like John's very involved with it. Daniel's very involved with it. I mean, you've been involved with it over time. I've done some stuff, but I think that's a really good one. There are definitely others. I think Zio JSON, there's some things, Zio SQL, but yeah, if anyone is interested in contributing things, I think feel free to reach out, and I'm always happy to point you in the right direction. All right.
Cool. Well, thank you, Adam.
Yeah.
And I have time to think of what to do next week.
Yeah. Have a great weekend, everyone.
Take care, everybody.
Bye.
Bye-bye.